Good morning, ladies and gentlemen. It is great to be here. My name is Julian.
And my name is Cindy.
Today we are going to introduce an experiment about the water resource. You might wonder, why is the water so important in our lives? Let's find the answer to our presentation.
Let's look about the table of content. My talk is organized in 6 parts. We will talk the first part about objectives.
Have you ever heard the water could actually snap your bones? I'm going to start with a little story about in the 1910 in Toyama, Japan. A mystery disease called Idai tortured hundreds of people because the calcium poison in the river. It was the tragedy that provided one thing. Ignoring water quality could cost our lives. After a little story, let's go straight to our heart of the experiment. The Long Onion in our Tochen River is the lifeline in our hometown, providing the water and rely on every day. As rainfall decrease and Baoshan River's level drop, monitoring this intent has become critical. Our missions go beyond data. We are here to ensure the quality and the sustainability of the water that powers our lives and our community. However, here's the problem. Our water source has faced two threats. First, pollution risk. The upstream Zudong landfill threatens our water with potential waste leakage. Second, political concern. The Hsinchu Clean Water Coalition and our community are damaging to know what's actually in our water. The experiment is our search for the truth. To provide the transparency our community deserves.
So the first point is our hypothesis. We believe that the water quality in the middle reaches is more deeply impacted by domestic swim than the upper reaches. As you can see on the map, the middle sections of the river is more closer to residence area and town. The second point is our experimental design. First is our independent variable, is sampling location. Second is our dependent variable, including concentrations of COD and other pollutants. Finally is our control variables. We make sure to use the same instruments and sample volume to keep our test fair. Lastly, I want to cover our data collection method. Everything repeat trial 3 times and calculate by taking average to keep our data accurate. So how do we actually see the invisible pollution in our water?
We use the spectrophotometer by checking light absorbed at 340 nanometer for CODs and 690 nanometer for spectrum. We can measure actually how much in there.
Using that to find pollutions? That's brilliant! What about the ammonia nitrogen? It's a big concern for the Hsinchu Clean Water Coalition.
For that, we use the conductive method It measures the concentration level quickly and accurately.
Perfect. Now we have the data to back up our concern. The next point I want to make is our experimental material. First, we collect water sample from upper and middle Tochen River. Second, we use tubes, pipes, beakers to handle this sample. Finally, we use test strip, reagents, and professional methods like these 4 things now you can see to measure water quality.
Now let's talk through the 6 steps of the phosphate analysis. Step 1. We use the pipette to collect 5 mol of the water sample and add it to the test tube. Step 2. We add 5 drops of the reagent into the tube and quickly mix it. And step 3. We add a level spoon of the reagent into the tube. Step 4. We shake it until the powder disappears. And you will notice the blue color started to appear. And step 5. And let the solution stay for 5 minutes and to allow the chemical reaction. And 6. Finally, we pour the sample into the phosphorus monitor set to the 690 nanometer to make sure the final concentration. And that's how we get our final data reading at 609 nanometer. Now let's look at the result. As you can see, the concentration in Na1 are much higher. First, COD is 26, which over 3 times higher. And second, phosphate is about 0.2, that nearly 10 times higher than this. And ammonia is also significant higher, like about 0.4. And most important, look at the P volume in red, like this. And they are and this extremely low number prove that the location is higher significant. Our data confirm the upstream region has the much higher pollution load.
2,000 years later.
In order to better understand this issue, we need to continue monitoring the water quality and look deeper into the resource of the domestic wagon. We hope our finding can raise awareness about protecting the Na1 upstream areas. Thank you for your attention, and I'm now happy to take any questions.